Okay, so welcome back. This is part 10 in our series where we show you how to program your test instruments. And we're using Visual Studio and C#. You can use whatever development environment and programming language you want. These concepts apply to just about anything. And we're going to show you how to develop this application where we've been talking about for the previous videos in this series. And what this application does is it's got a couple of functions. It allows you, first of all, we started out developing a frequency response analysis software. You can see up here your signal generator, and you connect to your oscilloscope, and you vary the output frequency of your signal generator over a range of frequencies and apply that to whatever circuit you want to test, and you measure the output of that circuit using your oscilloscope. And you can plot that in this application. It's called a sweep frequency response analysis. And also we showed you how to add functionality where you can grab the waveform shown on your oscilloscope and plot it here, and also save that data and analyze it in this application. What we're going to talk about in this video is how to continually update. What you see here is continual updates of this waveform on this application. We're charting the waveform from the oscilloscope. And what we can do is we can change which channel we are viewing, either channel 1 or channel 2. We're going to use these check boxes to select. And in future videos, we're going to be able to plot multiple channels at the same time on this scope. But in this video, we're just going to show you how to do continual updates. And in this case, we are doing it every 0.2 of a second. And we're continually updating the data. So what do we need to do to get that additional functionality? Well, we're really close with what we have so far. We've made a few little modifications, but in the previous videos, we had a little button here that allowed us to grab a single waveform from the scope and plot it. And each time we pressed it, it would update that waveform. This was called BTN wave. And we just click on it, and each time it will update the waveform. So as you can imagine, we don't need to do a lot more if we wanted to automatically update. We already have a system timer with an event handler. And previously we were using this time step seconds for the sweep frequency response. And the user can manually enter, for example, 1.5. And every 1.5 seconds, it would update the frequency response plot. What we're going to do here is we're going to have a separate time step for the grabbing of the waveform. And the reason we're going to have a separate one is because typically you can grab a lot faster a single waveform compared to the sweep frequency response, which had to do a little bit more work. You had to set the signal generator to the right frequency, then read from the scope, and that took a little bit longer. Here, all we're doing is we're sending a command to grab this data, and then we're pulling it into an application and plotting it. So we've now got two time steps. We've added a text box where we can set this time step. We've tweaked this BTN wave to have different text that shows start waveform capture, and we added another button for stop capture. And here we're updating every 0.2 of a second. Really, we're using a lot of what we already had. We are adding in the top right two checkboxes to select which waveform we want to display. And in the future, we can modify this to show both of the waveforms simultaneously. But here we've got channel 1. We can start the waveform capture and shows channel 1, and then channel 2, and it shows channel 2, and then we can stop it. So we're using a lot of what we already have, but we're adding a couple checkboxes and a button. And let's go in and see how we actually did that in the code. So here is our application. And as we said, this is going to be started with this BTN wave event handler. And here's the BTN wave. And you can see there's not much to it. Again, we already have the functionality to grab a waveform. There's a method we use to grab the waveform. So all we need to do is to modify it to add the different time step for capturing. So in the BTN wave, we've gone through and enabled and disabled some of the buttons to make it a little bit user-friendly so they don't click a irrelevant button. But really all we've got here is we have added this Boolean called waveform equals true. And that is basically saying if I click this BTN wave, that means I want to go into waveform mode as opposed to the SFRA scan mode. We've set waveform equal true, and we now are using this capture time.text, whatever the user has entered in this text box, which is capture time. We are grabbing that, converting to double, and coming up with a new timer interval, which is going to be, in our case, about 0.2 seconds. So we've got the new timer interval, and we have enabled the timer. Again, this is the existing timer. The only difference is we've got a new time, and we are now in waveform mode. So we can go to the timer tick event handler and see what's different. Well, now we've got the scan mode, which is a Boolean. If you're in scan mode, that's true. And all of this code is what we had previously for the SFRA. We haven't changed anything. We are just putting it inside an if statement that only goes through this code if we're in scan mode equals true. However, if we are doing the waveform capture, if waveform is true, and we just set waveform equal to true, all it does is reads this scope waveform which we had before. So this is the method that will grab one waveform from the scope and display it. So really not much changed at all in this timer. It's just that we've added the waveform update to the timer 1 tick. So now we can go to the method. We already have read scope waveform, and all it does is it goes through and does exactly what we had before. It just calls this method that we've already developed. Now, one thing I have added is for these checkboxes to select which waveform gets displayed, either channel 1 or channel 2. And we've added an if statement here. If CHK channel 1 is checked, then we are changing the command to define the source of our waveform data that we want is channel 1. Else, if channel 2 is checked, we're going to say the source is channel 2. All right. So that's all we've done is we added an if statement that defines which source for the waveform we want. So that's about it. There's really not a lot. We're just now putting this read scope waveform into the event handler and changing the time step. Now, one other thing I want to talk about that we have added here, and that is this button. We're going to call it BTN capture, which allows us to save whatever waveform we have brought in to CSV. And we've already got a method to save lists, X and Y values of lists to CSV. So all we need to do is make sure that we direct the correct list that we've already grabbed when we captured this waveform. We just make sure that we call this save to CSV using these lists for the capture. So to do that, we go to BTN capture, and all it does is it uses the existing write data to CSV we developed before, and we are feeding it the X wave and Y wave values that define this captured waveform. So in our read scope waveform, recall that we have this X wave and Y wave, and when we save the data, the waveform points, we save X wave and Y wave. So all we're doing is we're saying, hey, use this X wave and Y wave and save that to CSV. So that's about it. That now gives us the ability to open this application, open the USB connection to the scope, set the capture time, and start the waveform capture. And now we can select either channel 1 or channel 2. And then in the future, we're going to have a video where we can put both channel 1 and channel 2 on the same display. And then now we can stop the capture and save waveform to CSV using the existing method. So that's about it for this one. If you like any of these videos, please hit the like button, subscribe, hit the bell notification. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.